Hello everyone, welcome to Arduino and My Robot. This is chapter 13, and in this chapter we'll be learning about pulse width modulation. So when I say pulse width modulation, I'll break this thing into three different parts. First part is pulse. So if you know that whenever you put your finger on your wrist, you can feel a throbbing, that is a pulse. Your heart is pumping the blood and it is moving in a cyclic form. When you try to hear your heart sound by placing your hand or by placing your ear on someone else's chest, you can feel the sound of lub dub lub dub lub dub. So that is in a cycle form. Lub, pause, dub. So that is the sound of pulse. Pulse means something moving up and down, up and down, up and down with a regular periodic interval. Okay, you see this symbol here, this is your heartbeat symbol. It will strike one time, it will pump the blood, then take some gap, then again it will pump the gap, and this is the life symbol. If it stops, means a straight horizontal line will be there. You might have seen in movies, uh, uh, when somebody is about to die, this line gets horizontal. So I'll not go into that monotonous life. So here we want everybody to be alive. So I'll request you to take two fingers and put on the hand, okay, where your hand should be just below your thumb, and be careful, try to listen that sound or try to feel that sound. Okay, you will feel a pulse. Okay, so if it is something like this smooth, it is going like this up and down like a sea wave. Okay, so that's a normal pulse. But if there is a peak, like you see that this is very sharp as compared to the first one, so this is a water hammer sound. Like you see this is very calm, but still there are pulses, up and down movement. So this is slow rising. Similarly, there are different other methods of pulses. Now you see one pulse is starting from here, it is going up to here, then it is dropping back, then again it is horizontal zero, then again it is moving up, it is constant at some point, then again it is coming down and then constant. So whatever this width of each um width of each uh, the pulse, okay, width of each pulse, this particular from here to here, this is called as width. This section is called as width. Now you can see similarly we have other options also here. One is this is moving up, it's constant, then down like this. Okay, so and another is this one, it is moving up this way like this and this way. Okay, now you see when we combine this number one and this number two, what is happening? We are getting this. So it is, you see no signal in this part, but we have no signal in this part. So what is happening when we are superimposing? We are losing signal here and here. Only left part is this center part. Same is happening here. Okay. So, and this symbol, this is a modulating symbol, modulating signal. What is having modulation means some changes are occurring to that. Okay. So there are two types of signals, digital signal and analog signal. Digital signals are that you can see in this form like digitals, on and off, on, off. This is if you consider this bottom portion as off, let me say it's 0, and this top portion is on, that is 1. So what is happening is the digital signals can be of two types, on and off. What happens to analog signals? In analog signals, we have up and down continuous cycles like this. Something like this. It is what? This is analog symbols. Now let's understand it in, okay. Now let's understand what is PWM, pulse width modulation, in more detail. So you see there is a bulb. So first it is off, then it is on, then again it is off, then again it is on. What's happening here? If you think clearly, what is happening here? 0, 1, 0, 1, 0, 1, 0. So what's happening here is it is following a pattern of 0, 1, 0, 1, 0, 1. So this is what? This is a digital signal. And for how many seconds our bulb is on, we can decide that is 2 seconds for right now. So let's say the 2 seconds at the width here. For how many seconds? 2 seconds. This is our width of our signal, width. Now, but what if we need to change in this the duration of lighting? Suppose we have to change from 2 seconds to 3 seconds or even 1 second. Okay, you have to change the duration of lighting. Or what if we want to change the brightness of the bulb? If we want to glow it more brighter or less brighter, how to do that? Okay. As here power is constant in all the way. Power means the electricity. Let's understand in layman term that whatever electricity is coming to it is giving it power. Okay. So now let's understand, to change the brightness we have to adjust the power that is flowing inside it. And if you remember, power is related to current and voltage, V into I. Okay, now let's understand it. As I said, the thickness, okay, that's what width. Here you see, I have written here width of the pulse. You see this number one and number two. If you compare it, you can see the number one is narrower and number two is more wider. Okay. And this line, dotted line here bottom, this is the average of this. Okay. If it is higher width, the width of the signal is higher, the average will be higher. And if the width is lesser, the average will be lesser. Let's understand in a different way. Suppose if I get three students are there. Okay, these are three students. One has got one, sorry, other has got two, another has also got one. So what will be the average here? 4 by 3. So average will be less, something 1 point something. Okay. Now let's understand, since this is thick, width is thick. So let's take it 10, 5, 10. Okay. Not 5, but 8. Since it's thick, 8, 10. And what should we take this? Let's take it not 21, but 18. Something like. So what has become it? 10 plus 18, 18, 36. 36 divided by 3, because we have three signals, 1, 2, and 3. So what's happening is 36 divided by 3, 12. So the average, this we are calculating what? When we are dividing, we are calculating the average. Similarly, here when this value 1, 2, 1 were lesser, what we got is lesser average. And here average is higher. Okay? Average is higher. So what's happening is pulse width. One more thing, you see the signal niche, at the bottom you see T, right? T is time period. You can consider it as a time period in which how many seconds it is going to repeat. The signal is going to be repeated or signal is going to be changed. How is that happening? In that case, if you want to understand that, that thing is called as time period. So you see from here, the signal again is going to start from here. So this point, sorry, this starting point up to this point is T. From here to here, this is T, time period. So what is basically pulse width modulation and why do we need it? So PWM is a great method of controlling the amount of power delivered to a load without dissipating any wastage power. Okay. So we can control the amount of power we are going to give to any component. This can also be used to control the speed of a fan. Suppose if you have a knob, you have seen in your room, there is a knob. It's written 1, 2, 3, 4. This is the speed of fan. Okay. So as soon as you turn it, the speed of the fan increases. How are you doing that? You are doing that by controlling the power that is going into the fan. Okay. So that is controlled by a knob. Similarly, we can change the brightness of our LED bulb, okay, or change the speed, or how to say, increase or decrease the speed of our mini car, means car or any robot by changing the pulse width. Okay, so if you need to control the speed or brightness on all those things, power, basically power, P for power, you can remember P for power, P for pulse width modulation. If you want to control the power, what you have to control is the width. Okay, if you need to control it, then use pulse width modulation to do that. Okay, now where do we use it? There are many different ways to control the speed of DC motors, but one very simple and easy way is to use pulse width modulation. Okay, now let's see this. How do we do this into our Arduino? What are the different pins where we can achieve that? So you see, wherever we have this tilde, this symbol is called as tilde symbol. Wherever we have this symbol on the board, that pin is used for controlling the power, that can act as a PWM. One is this, nice. Then we have 6, then we have 5, then we have 3, then we have any more? No. Also, you can see it is mentioned here digital PWM. You see here, it is mentioned digital PWM with that symbol. So that pins are where we will be connecting our motor to, because at these pins we can control the speed or the power. So when we just don't want 0 or 1 value, then we use PWM pins, and all such devices are connected to these pins on which there is a tilde symbol. We also change in command. So instead of writing digital write, if you remember in the past few exercises, what we did was digital write. But in this case, since we are not just going to put it as an off, on, off, but what we are going to do is we are going to make it more like analog. So here it's not on and off. Here we have to control the speed. If you want here, 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 where do you want it? You can rotate the knob, or you can rotate your pin, your device, to control the amount of current that is flowing inside it. So for that, we are not using a digital type. What we are using it? We are using analog type of pins. In that case, our command or our code will change. Earlier we wrote digital write. Now we will be writing analog write and analog read. Write is when we want to give command to uh, the devices as an output, and read is when we want to take input from the devices, like in case of serial input. Okay, so that was all, and I suppose you have understood the concept, but in case if you do not feel comfortable enough, do watch this video again. And still, if you find that you are not clear enough, do watch the next project video. And still, if you are left with some doubt, feel that you are there. I'm there with you. Just give a message on the app itself, and I'll connect with you or via with a call or message, whatever will be suitable mode. And we'll be discussing it on the live class next time whenever we will be arranging it, and we can solve your doubts then. I hope it's clear now, and see you in next class. Thank you so much.